I didn't know it was going to become like my life's mission to get open source to succeed in that space.
Today, I'm joined by two people who have shaped how millions explore and visualize data. Max Beauchemin, creator of Apache Superset, and Evan Rusackas, Apache Superset PMC member and developer advocate, who have been building and growing the Superset community and Preset, a company based on Superset.
We're not only like the Swiss Army knife for connecting to any type of data at any place. All these different orgs that have been contributing and individuals that have been contributing to Superset, they deploy it in different ways. They have different types of users.
In this conversation, we dig into how Superset grew from a hackathon project at Airbnb into one of the most powerful open source BI tools in the world, and why open source changes the game for business and geospatial intelligence.
Geometry is a huge one as well, right? So I think if you want to build a tool that exposes data, you really need to take that into consideration as a core deep dimension. It's a dimension of its own. It's probably the most intricate one.
We also explore how geospatial became a core part of BI at companies like Lyft, Uber, and beyond, and why the map is often the star of the dashboard.
I think it was right around the time where I moved to Lyft, where there's a clear need to bring geospatial as part of core business intelligence internally. We're just finding Deck.GL, its existence. I think it was fairly early, right? 3.1.0, and just being blown away by just the quality and the awesomeness of the library.
This episode is packed with insights on business intelligence, open source, and the future of geospatial analytics. Future spatial, so let's get into it. So welcome, everyone. Excited to have Evan and Max here from Preset. They are helping build a company called Preset that is building and integrating around Apache Superset, which is an amazing product that helps bring business intelligence as an open source toolkit in the Apache ecosystem. And we're here to learn a little bit more about their journey and vision for BI today, how geospatial fits into that, and a little bit more about how geospatial can start to fit into the modern data stack. So I'm excited to have a little bit of a different perspective from kind of the normal geospatial flow, but that's what's exciting about today. So yeah, Evan and Max, I'll kick it over to you to give a quick intro, and then we'll jump into it.
All right, I'll go first. I'm Evan Rusackas. I've been working with Preset and the Apache Superset community for exactly 6 years today, as a matter of fact. And I've been doing so in all sorts of different capacities, whether it's design or engineering management, but I'm mostly kind of a front-end eng guy, and I've been working on developing and growing our community and trying to help other people in the open source community on DevRel and developer advocate kind of grounds. And I'll pass it over to Max.
Yeah, so I'm Max. I started Apache Superset, I think it was in 2016, as part of a hackathon at Airbnb. So it's been a little while, and I've been working on it in some capacity since then. I am also the creator of Apache Airflow, and then started a Preset just around that time, or maybe just about like 6-7 years ago. So I've been working on BI. Bit of a story. So I started working on Apache Superset at Airbnb, and a few years in, I had the opportunity to go work at Lyft. And one thing that was really interesting, attractive to me at the time was the ability or the need to go work on real-time geospatial at Lyft. So I spent a good year, a little bit more than a year at Lyft, really focusing on everything geospatial and real-time support and Superset. So a lot of what is in Superset today is based on a library called Deck.GL that at the time was the clear leader in data visualization with good WebGL support. Pretty awesome library, and spent a fair amount of time and cycle to kind of start from that seed to bring in Deck.GL and expose the functionality as part of Superset. So super excited. Like, I think geospatial is super fun. I love data viz. I love geospatial. I love like visualizations that are information dense too. So I think geospatial fits that category. So we're passionate about all this.
That's great. I mean, it's funny because Deck.GL and I think Kepler.GL, that kind of ecosystem came out of Uber. You moved over to Lyft, and then it's a lot of innovation happened at these companies with a lot of geospatial data, and not around that, just of course everything around data as well. So you gave a little background on the origin story of Superset, Airflow, and your journey there. Let's dig into that a little bit and figure out, okay, why did you need to, and why did Superset need to exist? Why was there a need for a new tool? And really, what were some of the pieces that you saw as gaps in the space, and how did it evolve from there?
Yeah, so the origin story or the context in which this seed started to grow is, picture Airbnb around 2015, I believe, and then we had decided to use modern databases like Presto, I think was the main one. So we had Hive, Presto, and then we're onboarding Druid, Apache Druid. That's a real-time database, kind of OLAP database. And a lot of these databases just didn't work with the BI tools at the time. So there was no support, no good driver for Hive, Presto, and Druid. Druid did not speak SQL at the time too. So as part of it, I think it was a 3-day hackathon. I was like, I'll just build a little, exploration app. So you point to a data set, you pick your metrics and dimensions, and then we'll generate SQL and allow you to generate charts and save them. So at first, it was really kind of just a hacky tool to enable people to explore data sets at Airbnb on databases that were not supported by BI tool. We had issues with we had some Tableau licenses at the time, but not enough for everyone in the company. So they were too expensive. So we're shuffling licenses. And then, I was coming from Apache Airflow, some of the success there. I'm like, we need a really good open source BI tool. There's nothing out there. I didn't know it was going to become like my life's mission to get open source to succeed in that space. But, we got a lot of traction early on at Airbnb. A lot of people, just needed to visualize things quickly. And then Superset was just this exploration, like super easy exploration on top of a single data set or, virtual data set. And then I grew from there. I'm like, why don't we add a dashboard type feature? And why don't we add a SQL IDE in here? So it grew over time to kind of take over, a lot of Tableau use cases internally at Airbnb.
Yeah, I'm curious as to, within how Superset has grown, what really differentiates it? I mean, I've heard a little bit about some of the connectivity, and I think obviously being at the forefront of how these data tools are evolving, and they were at the time and they continue to, that's one big advantage. But also from, how you present data, how you bring those things in, what makes Superset different? And more importantly, I think within that, like, what's the open source advantage there? I'm always curious to understand, okay, within that, open source can iterate a lot faster. You can bring in developments from people external to the product. How have you seen that play out, and kind of what differentiates Superset from the Tableaus and the Power BIs of the world?
Well, I think, just to jump in there on that one, a little bit of the advantage of being open source is not just the speed you can move at, but the diversity of use cases you can support. So we're not only like the Swiss Army knife for connecting to any type of data at any place, but all these different orgs that have been contributing and individuals that have been contributing to Superset, they deploy it in different ways. They have different types of users with different types of RBAC requirements and all sorts of diverse scaling needs and security needs, and all of this stuff tends to come back home so users can benefit from it no matter where they're deploying it or using it. So its capabilities just kind of layer and layer and layer and layer as more people adopt the product.
Yeah, I mean, like, just unpacking the advantages of open source. I wrote a blog post a while ago that was about the future of BI as open source and unpacking some of the advantages that come with it from open source and how it translates in this space. But I would say, the power of the community is a huge one. Just having a real open source community with diverse set of contributors. Evan hit on that already. But then, no vendor lock-in. I think in the BI market, it gets pretty expensive, and it goes against the idea of like democratization. So if you really want to democratize access to data in your company, but you're fighting against a certain set or price constraints, you can't really do it. So I would say there's a lot of good dynamics around that. I think, there's a bunch of other things that come from open source, but the kind of stack that we use is slightly different than what vendors might use, or at least like the incumbents might have used. I think Tableau is all like Windows 32 component, probably not anymore. I think they moved to WebGL. but we're able to use the whole ecosystem and awesome libraries like eCharts, but really the tree of dependency of Superset is gigantic and super powerful, and that allows us to build things in a different way.
And for that matter, it allows anyone to build anything. It really is the truth of it. At the end of the day, in my prior org, we were stuck trying a whole bunch of different BI tools and wanted to customize certain things. And you're never going to be able to get some of these little features and customizations you want on some proprietary tools roadmap. You might be waiting for years or decades or forever, where in this world, you can actually just open a PR and contribute something.
Yeah, maybe a few other things too, I think and maybe just looking from a UX perspective, like how is Superset different from these other tools? If you remove the philosophy or the open sourceness, I think we come from a background that's a little bit more technical. So there's a few assumptions that are specific to Superset. Like one is the dataset centric approach that's similar to the Tableau extract approach. So generally, Superset is dataset centric. So we assume that you have your semantic layer is a table often, and that's a paradigm that's just easy to reason about for most people, right? You create a table with all the dimensions and metrics that you need. You point your BI tool to it, and everything just works easily. So no complex semantic layer, pretty lightweight semantic layer has been part of the ethos. Another thing is like SQL support is pretty deep baked in, so we don't have our own formula language or other layer of abstraction on top. We just go raw SQL in a lot of cases. And that goes from, you have the SQL IDE. We assume that some people in your team organization knows how to speak SQL. And that's just a native, slightly more native interface. You don't have to write SQL if you don't know SQL. But if you know it, you don't need to learn another formula, mini language or anything like that. So you can just use the raw power of SQL. Also, like another thing too, originally we had really powerful databases, at Airbnb and other places where I work, and people in the community just assumed that the heavy lifting was going to be done at the database level. So you have a large cluster with like 100 Druid nodes or, a large Presto cluster. We didn't want to have another layer of materialization or storing the data. So we do lightweight caching. But generally, one deep assumption in Superset is that all the heavy lifting is done by the database server or cluster, which, it has pros and cons, but then you can really invest on that layer and assume Superset is a much more lightweight, fast tool on top of your big database cluster.
Yeah, that's what I've noticed when I first interacted with Superset. I mean, I've been a big advantage of shifting your workload to the right place. Like let the data layer do the heavy lifting, and increasingly with Geospatial, that's meant SQL. SQL has it feels like we're kind of like a few years behind, but eventually geometry or geography support makes its way in there. And then of course Geospatial kind of has its own world of tools, right? And I we have our desktop GIS systems that are really focused on map presentation, and then there's also been kind of tools that get I would say the most basic pieces of BI, a few filters and things like that, but the map is the star, if you will. So I guess what would be interesting to hear is when you think of geospatial data and showing that in a BI tool, what does that mean? Because I think I have some thoughts and ideas on that, but I'm really curious to say, like, when you say I have some lat long data or I have some polygons, what's interesting for you to put on a dashboard?
Maybe I'll get started on this, but like one thing to think about is when you look at data, there's a few core dimensions that are universal, right? Time is a huge one, but then geometry is a huge one as well, right? So I think if you want to build a tool that exposes data, you really need to take that into consideration as a core deep dimension of your data. Maps are super relevant. It's kind of interesting, guys. I went from Airbnb that was not that geo-centric to Lyft, where geo and real time is everything. So I think for different types of analysis, the geography is more important than others, but it's a dimension of its own. It's probably the most intricate one of all. In some ways, like time is linear and kind of unidirectional. Or you can think of time as a line or multiple lines at times, but geospatial, it's full like 2D, 3D. It's also like there's a lot of data properties that you can assign to different visual properties. So you can really, do very information rich things on maps. So that brings a whole set of challenges there for sure, right? The fact that you might want to take any property of your data up to maybe 7 dimensions, not just X, Y, but also, I don't know, potentially height and size and color and opacity, and map these dimensions of these properties of your data to visual properties of the map. And that brings some really cool stuff, but also some clear challenges.
So I think at the end of the day, a good dashboard is all about either discovery or storytelling, where you're usually either trying to find or present, trends and outliers in your data. And, time series analysis does that in many, many use cases, but not always. Sometimes just seeing that dot that's in a weird place on the map will show you something that stands out. Or if you want to see just how something is taking over the globe, having that perspective in a visual way is a really quick way to grok the information and find things that either are establishing a pattern or going against one that you're looking for.
Yeah, what I love about Superset, and I think it is always nice to challenge and push yourself a little bit. So I'm my career has been all about the map layer, right? How many layers, interactions, visuals, all these different pieces. But what was really nice was to think of it from somebody who's maybe not initially approaching a map, right? And I think that's probably the majority of people interacting with data. They're used to dashboards, charts, all these different pieces. And then having the ability to even better, make sure that data is up to date, if it's, changing anything under the hood there. So what was great was, we had a project, we were kind of doing some large scale analysis on walkability scores, right? And you could dynamically query, right? That interoperability with SQL to just ask a question and get a response. But the majority of the data was, non-spatial, right? What are the best cities or the best regions or things like that? And you could easily create and present that data with Superset. Docker image really ready to go and quick and easy setup. But as you mentioned, I think Max at the top of the show was, you also, when you did add mapping layers in there, you brought in some of the best, open source libraries that there were, Deck.GL, I think, being one of them. And then also adding in some different pieces like we used H3 cells. So adding spatial indexing as a presentation layer and things like that. So can you kind of talk about, when the journey for geospatial inside of Superset and kind of where that lives today, and then what that looked like also from when you were deciding how to bring it in, how you landed on Deck, and then what that process looked like.
Yeah, I think that there's a fair amount to unpack here, but I remember or maybe starting with just geospatial being a core dimension. I think people expect for a dashboard to show some geospatial. The classic, if you Google image search dashboard, you're probably going to see like half the dashboards are going to have some sort of map representation in there. There's also clear use cases inside most organization, like Airbnb, Lyft certainly, Uber for sure too. But there is a need to represent that the data in that fashion in some capacity. I think I'm trying to remember if that's when, I think it was around the time where I joined Lyft. I forgot if we pushed Deck.GL and started building. I think it was right around the time where I moved to Lyft, where there's a clear need to bring geospatial as part of core business, business intelligence internally. At the time, I remember connecting with the team at Uber, just finding Deck.GL, its existence. I think it was fairly early, probably pre 1.0, and just being blown away by just the quality and awesomeness of the library and usability. And like all these React components I can just drop in and use. I can layer these things very easily, right? All the constructs were there. The API was beautiful. And then I met with the team there early on at Uber, and the actors and the maintainers and builders were completely amazing too. They're geniuses, building some really awesome libraries and next level in a lot of ways, right? WebGL was fairly early back then. So I was like, we got to bring that in. This is just amazing. And then joining Lyft, I joined with that premise to improve, join the data platform team, knowing that geospatial was going to be a huge component of everything that is done at Lyft. So that happened early on. We look at Kepler too at the time. So Kepler was being built, or came out at some point around then, and it felt like having a BI tool inside a BI tool, right? Like Kepler is pretty opinionated, it has its own interface and usage UX patterns. It's fairly complicated, so we had to kind of encapsulate that. That didn't work so well. I think there's still an open PR that never got merged from that era, trying to bring in Kepler inside Superset. But yeah, I think we had like a fair amount of success, internally at Lyft, building just like deploying tools that are super useful. One thing we talked a little bit about this, but about SQL and pushing down, there's definitely some challenges where NC SQL is pretty kind of standard, like dialects are slightly different, but the geospatial libraries in SQL are different from database to database, meaning the SQL pass-through is powerful in that context because you can write your own SQL expression, but it also means the interoperability, and you get kind of issues around lowest common denominator across the geospatial stack across databases is not the same. So we try to just pass through things, but there was definitely some challenges around building on top of SQL in a way that would work on top of different analytics databases.
Yeah, and then I think, Evan, you're on the product management committee for Superset, correct?
Indeed.
Yeah. What were some requirements that you looked at if you're going to bring in a geospatial library, or what would you consider generally if you're bringing in some tool, something external to Superset? What are like some of the standards that you want to see in place to add something like that into your product?
I guess it's a mix of things. Ultimately we need to make sure that all the boxes are ticked in terms of contributability in the first place, whether that's licensing, things like that for any dependencies and packages. But then otherwise, it's kind of about the maintenance footprint and the testability of it all. If people are willing to contribute this in a way that we, the community, can maintain it, or they're making some kind of, major commitment to maintain it themselves and then deal with any bugs and additional feature requests and stuff like that, then we're open to it. And we have this whole Superset improvement proposal, or SIP, process that people can go through. I think there's a couple of these in this space actually, where you just kind of get consensus from the community that yes, we want to adopt this as something in our product, and we're willing to take on the maintenance of it. So given that, as long as people add tests to make sure this thing remains stable over the coming years, then we're all good. We're very open to broadening the horizons of what the product's capable of.
Yeah, it's like within reason too. I think in this particular case, shipping it as plugin would have made sense maybe earlier on. I think we brought it to the core code base because we thought it was just core enough at the time. Maybe this predates some of the SIP process too. But I think the beauty of Superset is like we support visualization plugins, so you can have your own NPM packages that are maintained in different repository by different set of maintainers at different cadence of releases. I think that's ideal in many cases. We're actually working on making Superset a lot more extensible and more plug-in architecture. So there's a lot there that Evan can talk about.
Yeah, so maybe just to sell the future a little bit, it's a very active project right now that went through one of these SIP processes, and there's going to be a few more rounds of that coming. But we're trying to re-architect Superset a little bit, so it's more like the VS Code extension system, where you can actually hot load all sorts of front-end and back-end extensions to just bolt on or replace different capabilities of Superset with third-party modules on the fly, whether it's you as an administrator enabling them for everybody, or you as a user enabling them for yourself. So there's a whole bunch more coming there, but it obviously opens not just the door to additional visualizations, but potentially other different, control types and, you name it, number formatters, data formatters, anything.
Yeah.
So that's all coming soon.
That's awesome. I really enjoy that approach because it allows for, you to kind of pick and choose what you want to add in. And then if you want to build it, that makes that process a little bit faster. Plugins are one big thing in QGIS, which is like kind of the most popular desktop GIS system. So if to draw a parallel from this audience, that's probably I think one of the closest parallels I could draw. But then the ability just to quickly add in those pieces would be sounds really great. And just to bring it back, you mentioned Kepler-GL. Kepler only added SQL kind of query compatibility within the last year. So Superset and Preset, you guys were way ahead of the curve there, just in terms of writing SQL, getting map, which I think is really great. And it's one of those things where I feel like Geospatial, sometimes we kind of want to have our like own tools and things like that, but obviously there's a huge value in interoperability and bringing those things into the wider data ecosystem. This is one big thing we've been working on at Whereabouts. We just pushed in spatial support for Iceberg, and that like didn't exist until, it's still going, it's going to come in the next release, but like it's there now. And, that means a lot of different things, and getting those data types closer to other data and all these different things. So I think I guess, first question of two parts here that I just kind of teased, understanding, how do you think of the geometry just as another data type, right? This has been a big discussion is, if, you're probably looking at all these different data types and formats, time series, all these different things that matter to someone presenting their data. How does the geometry fit in as just another data type, and how can we as a spatial community do more to bring that into these, modern data ecosystems?
Yeah, I have to dig in my memory to remember all the concerns at the time, but it was certainly super challenging, I think, to deal with the different data types there that were not formalized at the database level in any way at the time. So there was, a lot of like pure GeoJSON, if I remember well. In some cases, we're able to leverage, arrays to put in lines, or structs of the complex data types. And then since there is not a lot of standards other than GeoJSON, I think processing that in the back end and in the front end was unsettled in many ways, so fairly challenging. I think having a lot more standards would really help there, to have a more kind of constraints and guarantees for the people who are building on top of these things. So glad to hear about the Iceberg, like standardizing some of these formats. All this area are areas where database haven't really agreed on any standards. So if you look at the progression of NC SQL, it goes back to the 80s, that people agreed what is SQL. But since then, people have been kind of forking to how, their interpretation of like how you should truncate a date or how you should handle an array. I would say it's still fairly recent. I would say past maybe 10, 15 years, which is not ages in tech, but that complex data types are more accepted and used in databases to just support things like array, structs, dictionaries. They're called differently, and all the functions around all these things are different from a database to another. So if you want to do a map or reduce operation, or for each in an array, there's different ways to express that. So that makes things extremely difficult, I think, to build just one thing that works for everyone. So we really, at the time, we really needed data types. I think we reverted in a lot of cases just to JSON. So just put a string field, and we're going to tell you what we expect. And some of these decisions probably were not made by consensus, maybe just by what I needed at the time while I was at Lyft to build something, but trying to make decisions that would carry forward in some capacity, right? And expecting that people could write a SQL function to reorganize the data in a format that we accept somehow. I think there's some libraries in the back end. I forgot, but there's one or two Python geospatial library we needed to compute distance and things like that. So we could do some things on the results. So if it needs to be done on the raw data, I don't know, so we would typically do that in SQL as much as possible. And in the result set, we can do things in data frames and in pure Python, which is where there's generally like good, not performant, but like good data libraries, and somehow pass that over to the front end and make it fit in Deck.GL. So a lot of the features that are supported in In Superset, we're just directly informed by what Deck.GL could do and try to hardwire that to any database backend.
And on the database backend, if you're using Postgres, you could use PostGIS as an extension or something like that. So as long as you can connect, we're pretty agnostic about how you get stuff in there to visualize.
Yeah, I remember at the time too, BigQuery was super innovating around the geospatial stack. So they produced some really great libraries, and there's PostGIS. I think in every database would be like, oh, we have a bunch of UDFs, to compute distance, or do polygon overlap and all these things. So it becomes a little bit tricky for us to say, what you're going to express at SQL in your engine. And I don't think we ever got too deep into trying to build, call it like a multi-dialect support. So our approach, I think, back then and still today was to say, like, hey, you give a SQL that returns a certain format, and then we take it from there. But yeah, one challenge is if you want to push down some features like compute, like say if you want to do spatial aggregations, there might not be a common function across all the databases to do it. So then we need to manage, inside Superset, we have a big package that's around like supporting multiple dialects, right? So everything that SQL Alchemy, which is a library we use, that is not supported by SQL Alchemy, we need to manage how we're going to translate things like date truncation or substring search and this and that. So for geospatial, we never really got into that layer of detail of saying like, oh, what's the function that maps to what I'm trying to do to push it down. So generally we would just say, provide a SQL expression that returns something that fits this format.
Yeah, there's I think last I counted, there's at least 40 different SQL-based tools or tools that have some sort of SQL layer that support spatial functions, be it just having a geometry or geography, up to PostGIS, which has the most and includes nearly everything under the sun, right? But I think what's been interesting, or I think great over time, is that more and more tools are adopting SQL and having spatial functionality in there. And then that allows more people to interact with it, even if it's just building a basic geometry, translating that into GeoJSON to bring up to the front end or anything like that. But more importantly, bringing that data closer to more of the modern data stack and more interoperable tools. And I think what the case I hope to make for folks listening is that there is a ton of value in bringing your data into these tools that are more interoperable, more connected into the modern data ecosystem. And I guess from your perspectives, what is the value of kind of having or being a part of the modern data stack and having interoperability? I've tried to talk a lot about this to this audience because we tend to have an acronym or a moniker that spatial is special, and it needs to be treated in some special way, and it kind of lives separately. But I think there's a lot of value in collaborating with and working with these tools that are nearly everywhere, and I think that's where the data ecosystem is going. So just from your perspectives, having been in this ecosystem, being an active part of it, what does that mean to you?
You want to get started, Evan? I'm trying to think through all the different points here.
Yeah, I'm trying to think of that too. Well, the last thing I want to say to an audience is that you shouldn't consider yourself special, but really geospatial data is just one facet of data in general. So I think one of our MOs here at this project is to just be able to visualize any and all data. So bringing that to the table and kind of creating a bigger picture that surrounds all of your geospatial data is important to us.
I'm thinking of a few things too. So on one side is, with GIS tools that are desktop bound, you're kind of limited to the compute power of your laptop or, your desktop, where, in the big data world or whatever it has become, you have clusters of machines that can work together on extremely large data set. You can support all sorts of other data types, or, it's easy to make a dashboard that has some geospatial visualization mixed up with all sorts of more traditional charts too. You might be able to even do like fancy tooltips, that show a different facet on top of geospatial. But yeah, I think that the main thing is not being limited by, your laptop. There's something around sharing too. So if I need to have a GIS tool, you need to have it too, so that we can share. Like our stuff is all web-based on shared tools and
that's what I was going to say. I think there's a democratization angle here too, that, typically with the BI tool, you're going to have all sorts of different audiences that are in there using it day to day, whether they're, a marketing person doing some sort of analytics, or sales, or you name it, all sorts of different departments and teams. And if you can put your geospatial data in a place where they're going to actually see it on their day to day, then, having eyes on that is more valuable than having it siloed somewhere else in a tool that they don't access day to day.
Yeah, I think you win on the whole pipeline too. If you think about like tools like, Airflow and DBTs, if you need to do processing at scale, you want to add some CI, some data quality checks to your data, making sure you don't have a geospatial from another planet landing in your coordinates, But yes, I think there's the whole ecosystem too is really powerful. Maybe it's sometimes too complex. If you have a CSV, you just want to visualize it, it's probably not the right approach. But yeah, there's a lot that exists in that ecosystem you can leverage with geospatial data.
And it's not just visualizing. I know we've been focusing on that, but we do have other features around alerting and reporting and things like that. So you can set SQL queries that have thresholds. And if you can alert people when something changes in your geospatial data, that has value too.
Yeah, there's cross filtering is also interesting. So if you do mix, geospatial, you have a map or multiple maps on one side, and you have maybe some line charts, some bar charts, some table charts. You can get some pretty good cross filtering stuff out of the box with Superset. So you might be able to click a data point on a map, and it will filter, a table with some sample, itemized row data of the composition, kind of unpacking, drilling across, click on a city, on a market, and then you see a set of metrics adapt to that. So I think that there's a lot of power in this interactivity, cross filtering, like dashboard interactivity.
Yeah, there's a project we've been working on, which is there's this amazing data set of river gauges, because this doesn't sound crazy exciting, but measuring the height of rivers all over the United States. It's about 10,000 sensors, so it's not massive data, but it updates every 15 minutes, right? The problem is the NOAA, not the person Noah, but NOAA, they just push a shapefile and they overwrite it every 15 minutes. Once the data is there, it's gone. No historical record, but it it can tell you everything about floods, rain, so much information going on. So we've been, setting up an airflow pipeline just to collect that data, pushing, doing some basic cleaning of the data, getting what we don't need, what we want to keep, and then pushing that to an iceberg table. And then with that, I can just have the current view, I can have snapshots, I can get alerts, I can, do all of that. So, Superset and Preset seem like the next logical step to making that really accessible, both from a, okay, where's flooding bad in terms of, not just on a map, but which states, which river, bodies, anything like that can add, a ton of value. Yeah, I think kind of last questions I had, how do people get started? I mentioned getting, on the open source side, getting started with some of the Docker packages. I've been pushing Docker quite a bit because I've just found it so useful to create kind of your own stack locally. But if they want to get started with Superset, where they go, and then how do they take their projects and lift them into Preset?
Yeah, so on the open source side, yeah, Docker's the way to go, just to run it locally and get up and running. Just Docker compose up. It's that simple. And there are instructions on the Superset website of how to deploy that for production. But I also should say that probably the easiest way to try Superset in general is to do so on Preset. We have a very generous free tier that's not just for a couple of weeks, but actually forever, for 5 people to use one Superset instance. And so you can just get cozy there. And that thing Max mentioned earlier about vendor lock-in is very true for us. There's import-export tools and a CLI on both sides, so people can port from Superset to Preset or vice versa. So yeah, just click the button, and if people actually start to glom onto it and add users, you can swipe a card and get more seats.
Yeah, we won't be upset if you use Preset just for a POC, to evaluate Superset and then start running on your own. So we realized a long time ago that the most successful Superset is, the more successful we're going to be in the end too. So, we're all about having a free tier, and then have like a better offering for people who want more service. They want to manage service for a fair amount of people. So we specialize in that.
Yeah, I think it's maybe a little bit different because with the open source tooling and then this ability to just move seamlessly in between a cloud tier, your local, scale up if you need. That hasn't always existed in our space, and I think that it's something I encourage everyone to do. Go check it out, sign up, and build some different dashboards. And there's just an endless amount of ways you can connect data in, which is the really nice part too. So definitely take a run at that. I'll be building a tutorial, which I may or may not have just teased earlier here. So I'll share that. So if you watching this at a later date, you can check that out as well. I'll link that here once that comes out. And I just wanted to wrap up with. Oh yeah, go ahead.
I wanted to say something. I think so. I think in this space, there's a lot of CSV probably and kind of local data sets too. So on preset, and then I think in Superset too, you can upload CSVs too. So if you come on in and you don't necessarily have a database that's publicly accessible, right? So if you want to connect preset to your Postgres, and it's local, it's behind a firewall, we can't really access it. Though we do have like a SSH tunneling and this sort of features. But yeah, so you can upload a CSV too if you just want to test drive preset with whatever data sets you have locally or remotely, as long as it's connectable to.
Yeah, perfect. Yeah, I like I said, definitely get in there and jump in. And even if you're not running a full data system yet, you can get the ball rolling pretty quickly, which is what I love about it. Last thing, just kind of want to do a quick rapid fire round, something fun to wrap it up. But yeah, what's your favorite open source tool besides Superset, obviously?
Airflow? No. Actually, no. I got to think about. I got to think about it. Maybe I'll mention just some dev tools I found recently. But those are called Ruff, RUFF, and UV. They're like just awesome libraries for. Ruff is for very fast linting in Python. So the toolkit for like code quality, linting, code formatting, replacing like 15 different tools we had to juggle with in the past. And UV replaces pip compile. There are a lot of pip ecosystems. So it's just been awesome to have a set of tools that are just like extremely fast. I think they're written in Rust, and it makes all of us that much more productive.
I guess I've got kind of a couple answers. One is some of the Lego brick that you can build stuff with now just blows my mind. On our project, we're using Ant Design, and we're using for components, we're using Emotion for styling, we're using eCharts for our kind of core visualizations. All of those things keep getting better and better over the years, and the rate at which you can build and improve things now is nuts. So thanks to those projects. But I guess everybody's talking about AI. So the AI thing that I'm kind of in love with at the moment is something called RuCode. It's just this very agentic IDE kind of workflow where you just tell it what you want to do, and it starts actually, writing stuff to your console or whatever permissions you grant it, and you can just go have a cup of tea and come back and your work's done.
I got a +1 on the toolkit. There's some of the big chunks that we use to build Superset. So Undesign 5 is amazing. It's a super great theming engine. So we're going to be supporting full theming, through this awesome library. eCharts is just like a very rich, no dependency tree library. It's just like a self-standing library, which is remarkable in the Node ecosystem nowadays. To have just one library that doesn't bring 100 other dependencies. And then Deck, I think Deck.GL is just a marvel of engineering too, especially if you think about when it came out and demonstrated what you could do with WebGL at the time. It's pretty awesome. There's a new PR now that originally we had to support Mapbox. That's not really open source. Apparently now it works with OpenStreetMap. So next version of Superset is going to have OpenStreetMap, which all these projects are completely amazing, and Superset would not exist if it was for us to build all those building blocks.
Yeah. All right. Most underrated feature in Superset.
I'm going to say handlebars. Actually, I used a little bit of that in a demo that I can show if there's time. But yeah, if there's not a chart built in that does something you want, you can probably rig it with handlebars if you're pretty handy with HTML and CSS.
Yeah, I'll add on. I added some features actually for the geospatial stuff early on. So the problem was that there's so many data properties that we needed to map to so many visual properties, right? I mentioned it before, but the size of the circle, or this elevation of the, so there's probably a dozen or so properties you might want to map in super intricate ways. And originally I added a control where you could write JavaScript snippets to say how to map visual data properties to visual properties, allowing you to tap deep into the Deck.GL framework. But these features have been feature flagged off because they're deemed non-secure, because we're running JavaScript code. So it would be total code injection potentially, though if you use it locally, right? So if you use Superset locally or in a trusted environment where only administrators can publish JavaScript code, yes, they can run JavaScript code on a remote machine, but in a contained environment might be okay. And I think that's potentially really powerful. Like we'd love for the long tail of, you look at these visualization libraries and they expose very complex data structure as to whether you want to show the tooltip or how you want to build it, what you want to compose into the specific tooltip, which shade of color palette you want to use for this specific type of object. So for all of this, I would say the low level, opening the door to low level can be extremely powerful, though it has potentially security concern in larger environments.
Nice. All right. And then one last one, advice for folks from Geospatial creating their first maps or first dashboards in Preset.
Well, I think for anyone that's new to a tool, reach out to the community if you get stuck. Find us on Slack and then ping me. We're always interested in hearing where people get stuck so we can make the product better. But in general, just have fun.
There is a dashboard. So when you Docker Compose up, when you do the normal, just local installation to the sandbox, there is a Deck.GL dashboard that shows 5 or 6 visualizations. So you can start playing with that. I think you might have, until recently, you needed a Mapbox API key if you want the tiles. So you'll be able to interact with the kind of layers on top of the visualization, but you won't see the map unless you provide a Mapbox API key, which is pretty easy to get. I think next version of Superset, it will just work with OpenStreetMaps right out the gate. But yeah, I would start there to look at the dashboard, and from the dashboard you can interact with the charts, see how you can interact with them. But once you edit the chart, you get into our Explorer view, and then you should give yourself a tour of all the controls, right? So there's a lot of like, how you want to build your tooltip, and how you want to set up your charts. There's tons and tons of controls there, so you can play with those. Good place to start.
Perfect. Well, that's everything I had. Evan, Max, thank you both for taking the time to join today. Excited we got to bring some new perspectives to our spatial community, and hopefully bring some of the spatial community over to the Superset community as well. So really appreciate it. I'll drop your information, how to get started, and some different tutorials down below in the episode notes, so you can grab that there. But yeah, both of you, thank you for your time, and really appreciate having you on.
Awesome. Thank you. I wonder, is there a place where people typically comment or ask questions? So once you publish, is it like a YouTube video? There would be like comments too, because we can come in and answer a bunch of questions there too if you.
Yeah. I'll splice this in. And then if you have questions for Evan and Max, if you're watching this on YouTube, and I believe Spotify as well supports comments now, you can drop comments down below. They are more than willing to jump in and answer some questions and comments there. So don't be afraid, share some comments there, and you may see Evan or Max pop up in your comment section. So.
All right, looking forward to it. Thank you.
Awesome. Thank you both.
Thank you.